Today we're going to continue using nets to determine the surface area of three-dimensional figures. Specifically, today we're going to be focusing on rectangular prisms and cubes. We have two objectives today. They are that we can determine that a right rectangular prism has 6 faces, top and bottom, front and back, and 2 sides, and that we can determine that surface area is obtained by adding the areas of all the faces and develop a formula for the surface area of cubes and rectangles. Here we have a net of a rectangular prism. Let's take a moment to find the rectangular prism in your geometry kit. In the previous lesson, we focused on calculating the surface area of a figure by adding up the area of each of its faces. In today's lesson, we're going to look for patterns in the surface area of rectangular prisms to identify a formula to calculate surface area. To begin, pause the video while you calculate the area of each face of this figure. Unpause the video once you've labeled the area of each side. We now have the area of each side of the rectangular prism. Let's organize this data into a table to look for patterns. What patterns do you notice in our table? One thing that I observe is that there is 2 of each measurement. Both the top and bottom have the same area, the left and right have the same area, and the front and back. This definitely seems like it could be a pattern to watch. Let's see if it holds true after another example. Here's a new rectangular prism with different dimensions. Go ahead and calculate the area of all 6 sides of this prism and record them in our table. Pause the video here until you've found the area of each face of the figure. We can see that again, the top and bottom, left and right, and front and back all share the same areas. There's definitely a pattern here. But how can we record that pattern as a formula? Let's break down how we find the area of each face. Let's start by looking at the top and bottom faces. We calculated these areas by multiplying the length of the prism by the width of the prism. To help us begin building a formula, let's record the top and bottom as length times width. Now let's look at how we calculate the left and right sides of the prism. To calculate the area of each of these sides, we multiply the height times the width. Let's record this side area formula in our table. The final 2 faces we need to examine are the front and back of the prism. We calculate the area of these by multiplying the length times the height. To find the surface area, we need to add up the area of all of the sides. Let's write an expression to show how we would do that using our variables for length, width, and height. This is technically a formula for surface area. Unfortunately, it's so messy that it doesn't seem very useful. I do see, however, that we have duplicates of some of our operations. For example, we multiply length times width twice. I remember from our work with the distributive property that we were able to combine like terms like this. Instead of adding the quantity of length times width and the quantity of length times width, I can simply multiply the quantity of length times width by 2. This begins to simplify our formula and make it far more useful. Let's do this with other like terms in the formula. Now that we've gotten our formula to this point, we can even remove the parentheses and multiplication symbols to condense the surface area formula further. We now have a working surface area formula for rectangular prisms. Record this formula in your notes. Note that this formula will not work for all 3-dimensional figures. Just like our work with 2-dimensional shapes, each different figure requires a slightly different surface area formula. I know that a cube is a specific type of rectangular prism. This has me wondering, does our rectangular prism surface area formula work on a cube? In this instance, the length, width, and height of our cube are all 9 centimeters because all of a cube's sides are equal. We can substitute these values into our surface area formula. This formula will work for a cube, but we can simplify this formula even further for a cube. 9 is the length of one side in this example. Let's replace this with the variable s. Because all of the cube's side lengths are equal, s is the only variable we'll need. Because we're only multiplying groups of s, we can combine these into a single set of parentheses. 2 groups of s times s plus 2 groups of s times s plus 2 groups of s times s equals 6 groups of s times s. We can further condense this formula by representing s times s as s to the second power, or s squared. If we use the formula 6 times s to the second power, we can find the surface area of a cube. Go ahead and write down this formula as well, noting that it only works for a cube. You're going to use both of these surface area formulas on today's problem set.